Good morning, students. Today we will start with a program to control the brightness of LED while glowing using pulse width modulation at levels of 25%, 50%, 75%, and 100% respectively. Now, before going for the programming of pulse width modulation, let me explain you what does pulse width modulation is. So this is a diagram in front of you from which we can study about pulse width modulation. Now just observe here the rectangle which I have made. This rectangle or these two lines, this one and this entire thing is known as duty cycle. Now you can see here, for this entire duty cycle, the voltage is 0. So what will happen if the voltage is 0 for entire duty cycle? There will be no current passing through the LED and the LED will be switched off. Now just again observe the same cycle in the next step. So I will just add this part. I will make a line. So this is now the cycle in this part. Now if you observe here, in this particular duty cycle, for some time voltage is 5 volts and for some time it is 0 volts. And let us say this sometime is nothing but 25% and this is 75%. That means for 25% of time, it is getting an input of 5 volts and 75% of time, it is getting an input of 0 volts. So what will happen here is, if I show you the calculation, for 25% of time, so I can write 0.25. So for 25% of time, it is on 5 volts, so it will be multiplied by 5. And for 75% of time, it is on 0 volts. So it will be multiplied by 0. So if I just calculate this value, I will get answer as 1.25 volts. So what happens here is, instead of 0 volts in the first step, I am getting now here the average voltage passing in one duty cycle is 1.25 volts. So if 1.25 volt is passed in one duty cycle, LED will glow with that particular voltage. Now, how much brightness will be there? Now, as we have said that it is working only for 25% of time, the LED will also brighten by only 25%. Now, let us go to the next cycle, wherein you can see, again, I will mark the next cycle. So it is here, this one and this one. So this is the entire cycle. Now, again, if you observe carefully, this particular cycle, for 50% of time it is getting 5 volts and for 50% of time in same duty cycle it is getting 0 volt. So if I calculate, I will get 0.50, that is 50% of time it is getting 5 volts and 50% of time it is getting 0 volts. So if I calculate this, I will get 2.5 volts. So in step 1, I was getting 0 volts, hence LED was not glowing. Then in step 2, I am getting signal or 1.25 volts. So the LED will glow with only 25% of the intensity. In step 2, I am getting voltage as 2.5 volts. So that means the LED will glow with much more intensity than the step 1 or step 2. That is with 2.5 volts. Now again, if I go for the next step, then now you can observe that for 75% of time, LED is getting 5 volts and only for 25% of time it is getting 0 volts. So is for 75% of time it is getting 5 volts and for 25% of time it is getting 0 volts. So if I calculate this, I will get approximately, I think, 3.75 volts. So now you can observe that voltage is going on increasing. From 0 it comes to 1.25, then from 1.25 it comes to 2.5, then from 2.5 it is going to 3.75. So as the voltage increases, the brightness of LED glowing also increases. Now let us go for the final part. So now here you can see, for the same cycle, if I extend this part, for the same cycle, for the entire duty cycle, it is getting 5 volts. So if I again calculate, I will get For 100%, so I will write 1 into 5. And for 0%, it is on 0 volts, so I will get 5 volts. So now the voltage is from 3.75 jumps to 5 volts. That means LED will brighten by the full capacity. So this is nothing but the concept of pulse width modulation. Hope you have understood. One more thing to be understood here. In previous 2 lectures, we have used LEDs and we have connected it to digital pins. Now what does digital pin and analog pins means? Digital pin means it will take input either 0 or 1. That is, either it is off or on. It will not take values in between. So for digital inputs, there is only 2 possibilities, either 0 or it will be 1. It will be off or it will be on. But here we need to keep it on for various intensities. So that will go into the analog part. That will not go into the digital part. Digital means only off or on. It will not go into the middle range. So here I will write analog, wherein I can use any values between 0 and 1 or any values between, let us say, 0 volts to 5 volts. So this comes under analog. Now let us start with the programming part. So here it is, the circuit. One more thing to be observed is, when we tell it as pulse width modulation, then you cannot attach to any of the digital pins. Here you can attach only on this pins. Pin number 11, 10, then here it is 5, 6. The ones in which this sign you will observe, the sign of pulse width modulation. So the pins which has this kind of symbol, that are the pins which can give you pulse width modulation. So if you want pulse width modulation, you have to connect to the pins which has this kind of symbols. For example, if you can observe here, pin number 10 and 11 has. Also here some pin 5 and 6 also has the same pulse width modulation. Okay, now let us see how to convert or how to write a program. So first step, as I told, the first step is declaration of pin. Which pin of Arduino you are using. So as it is only one LED, I will be using only one pin of Arduino. So I will just declare the pin. Let us say I am using LED 1 equal to 9. That is, I will be using 9th pin of Arduino board, which is also you can see as a pulse width modulation pin. So this completes step 1. For step 2, I will write void setup, then open the bracket. Then what I have to do is I have to declare that the pin which I am using will be considered as output pin or input pin. So now because it is an LED, it will be giving me output. So I will write pin mode 9, output, and then I will close the void setup. So these 2 are the steps, initial steps. Then on step 3. Step 3 is the void loop, which will be running continuously, or you can say the logical sequence which we need. So I will write void loop and I will start the bracket. Now let us first understand the logical sequence. What we need? We need that our LED should be off. So I will write 0 volts. Then it will be brightening by 25%. So I will write 1.25 volts. Then it should go for 50%, that is 2.5 volts. Then to 75%, that is 3.75 volts. And then to maximum, that is 5 volts. So this sequence we have to follow, which we have to now put in the program part. So first I need 0 volts. So I will write, now just observe here what I am writing. I will write analog write. Why analog write? Because we are using pulse width modulation. We cannot use digital write. So the same sequence, the same syntax goes, but instead of digital, I have to write analog. So analog write LED 1, 0. So for if I write 0, it will be in the off state. And then I need to see it in the off state. So I will write delay of 1000. That is 1 microsecond it will be off. So I have achieved step number 1. Now for step 2, I need it should glow to 1.25 volts. So I will now write analog write LED 1, 64. Now why, from where this 64 comes? Okay. Now let us explain. Let me explain this. Now whenever you connect on these digital pins, this is 8-bit pins. So let me make the pins 8 bits. 1, 2, 3, 4, 5, 6, 7, and let us say 8. Now in this bit, you have 2 options. Either it will be on or it will be off. So I have 2 options. here also, here also, here also, here. Every bit can take two values, either it will be 0 or 1. Okay, now this is the first bit, so I will write 2 raised to 0. It is first bit 2 raised to 1, 2, 3, 4, 5, 6 and 7. Now if you add this 2 raised to 0, it is 1, plus 2 raised to 1 is 2, plus 2 square is 4, 2 cube is 8, 2 raised to 4 is 16, 2 raised to 5 is 32, 2 raised to 6 is 64 and 2 raised to 7 is 128. If you add all this, you will get total as 255. That means the entire 5 volt is corresponding to 255 as decimal number. 5 volt will correspond to 255 as a decimal number. So now if I want to write decimal number here and I want only 25% of 5 volt. So what I will do is I will just multiply this 255 by 25%. So if I do 255 into 0.25, which I want 25% only, so I will get 63 point something. So that's why I'm writing here 64. Okay, so with this statement, what I have done is I have achieved step number 2. Then I will write delay to see whether it has glowed to 1.25 volt only or not. So I will write delay of 1 second. So by this we have achieved step number 2. Now for step 3, which is here, I want the LED to glow by 2.5 volts. So now what I will do is, again I will write analog write LED 1, 127. Now again from where 127 comes? Total is 255 and I need only 50% of this. So I will just multiply 255 with 0.5, that is 50%. So I will get approximate answer as 127. So which I will be putting here. Then I will write delay of 1 second. So this from this we have achieved step number 3. Now I need step number 4. Step number 4 is I want to glow the LED by 75%. So I will write again analog write LED 1, 191. Now what this is 191 is? 191 is 75% of 255. So I will write 255 into 0.75. So it will come around to 190, 191. So just this value I will be putting here. And then again I will write delay. And then finally I want 5 volt, that is 100%. So for 100% I will directly write 255. So here I will write analog write LED 1 255 and then again I will get delay and then I will close the bracket. And now this entire cycle which is written in void loop will go on continuously. So with this program what is done? LED will glow in steps of brightness. So this completes the program. Now let us go to the simulation part and see whether the program is working or not. Now again I have taken two things, Arduino board and LED light. So as per our program we have connected LED to pin number 9. So I will connect this to pin number 9 and this to ground. So this is connected to ground. So that's all about the connection part. Now we have to go for the programming part. So I will go for code. Then I will just paste the code which we have just seen. So this is the same code which we have just studied, int LED 1 equal to 9 and so on. And just I will press the button of start simulation. So now you can see the brightness is very less. If you want to see it for some more time, what I will do is I will just increase the delay. Let us say 3 seconds delay I will give. So here also 3. Then there is no delay given here. So delay should be here also. Delay 3000. If you don't give the delay, you will not able to see what is going on. Then here it is 3 and here it is 3. Now again I will start simulation. So for 3 seconds it will be off. Then it is for 3 seconds it is intensity 25%. Then going for 50%. Then 75% and then 100.